In this section, I'd like to talk about why robots are useful. Why do we need robots? The first example I'm going to give is what's called robotic surgery, but that's a bit of a misnomer. It's actually robot-enabled surgery, and highly trained human surgeons are a key part of the system. The robot part of the system is shown over here, and there are a number of tools which are inside the body of the patient. There are tools which carry very small cameras, and the information from those cameras is presented to the surgeon in a stereoscopic or 3D display. The surgeon looks at this 3D imagery and adjusts what we could consider as some small joysticks. Those small joysticks control the motion of tools which are also inside the patient's body. So the surgeon is doing all of the skilled work. He's using his eyes to interpret the 3D imagery. He's using everything he knows about medicine in order to control the tools inside the human body to do the job that needs to be done. The key innovation here is that the surgeon is virtually inside the human body. In the old days, we needed to make very large openings in the human body so that the surgeon could get his very large hands in there to do the work that needed to be done. With this robot surgery technology, we're able to make a number of very, very small incisions in the body of the patient into which we insert these very small tools and cameras. So the outcomes for the patient are a whole lot better. So robotic surgery is really a misnomer. It's like the teleoperation system that we looked at earlier on, which was used to perform manipulation of radioactive material. It's a very similar technology being used here to virtually place a surgeon inside the body of a patient. We can also use robot technology to make us stronger. This is a technology called an exoskeleton. It's a wearable robot. We strap ourselves into it. It straps onto our ankles, onto our knees, onto our thighs, and onto our trunk. It monitors how we move, and it's made of very strong materials and it's got very strong motors. So as we move, it moves with us, and its strength augments our own strength. Here's a video of an exoskeleton system at work. This is some video that I took at a robot exhibition recently. We can see the gentleman wearing the exoskeleton is able to handle this large weight quite effortlessly. There we go. So this is a way that limitations of human strength can be augmented by robot technology. The intelligence in performing the motion or performing the action comes from the human being, but the raw strength, the brute strength, comes from the robot that he's wearing. Another really important role for robots today is managing assets. Our societies have a massive investment in assets in terms of power lines, water pipelines, gas pipelines, and sewer systems. And in order to maintain the health of those assets, they need to be periodically inspected, and that's very labor intensive. And some of these inspection jobs are fairly unpleasant. Imagine if it was your job to inspect sewer systems. It's dark, it's unpleasant, and actually a little dangerous. So people have been building robots that can be placed into pipelines to perform the inspection without sending human beings down there. So robotic researchers have been developing robot systems for performing this kind of inspection work. And here we see an example of a pipe inspection robot. It's got wheels to propel it through the pipe. It's got lights and cameras. A massive amount of money is spent each year on inspecting power lines, and there's a couple of approaches to doing this. One is to fly a robot along the power line, or else to build a robot that can crawl along the power lines. Flying helicopters near power lines is a dangerous business, and each year a number of helicopter crashes are caused by the helicopter coming into too close proximity with the wires that it is inspecting. So this is exactly the sort of job, a dangerous job, that a robot should do. Perhaps our most important asset is the planet on which we live, and researchers are developing all manner of robots to inspect and monitor the health of our planet. A few of them are seen here. There are flying robots that can be flown into dangerous weather systems such as hurricanes or cyclones, robots that can explore the inside of volcanic craters, blimp-based robots for monitoring the health of the Amazon rainforest, underwater exploration robots, Antarctic exploration robots, and even robotic boats for monitoring the quality of water in the storages that provide drinking water for cities. It's a dangerous business sending humans beneath the surface of our oceans. Human divers are limited in the depths that they can dive to. They also require a support vessel on the surface from which they dive and for which they return. Because of this limitation on humans under the water, there's been an enormous amount of research over recent decades in building underwater robot systems. These are completely autonomous, they've got a number of sensors on board, and we can send them off to do missions like photographic survey of wrecks, exploring for minerals, and examining the health of assets such as coral reefs. Another place that humans can't go is to other planets, and here is a collection of robots that have been sent to Mars. Here in the front we have the small robot Sojourner, which was sent in 1997. Behind that is a robot which is a copy of Spirit and Opportunity, which was sent to Mars in 2003. And over here we have this giant robot, Curiosity, which was sent to Mars in 2012. Here's an example of some pictures of Mars taken from the Curiosity rover, and again here we can see the size of the Curiosity rover with respect to a human engineer. The important message here is that there are environments that we want to go to learn information about the health or the state of the environment, be it deep oceans, rainforests, volcanoes, or other planets. But it's currently either too expensive or it's too dangerous to send human beings to those places. So we send robots there instead, and they serve as our proxies or our agents, and we use sensory information from those robots to learn about that environment rather than having to send human beings carrying instruments to those places.